The power produced by a force moving an object is given by the equation. Power is equal to work done over time, which is equal to force times displacement over time. Which quantities are scalars and which ones are vectors, O level?
Displacement is a vector. Time is a scalar.
So what's the correct answer?
So A is wrong. So it's either B, C, or D.
We're saying either C or D?
No. So
the answer
C.
is what?
Wait.
Power.
No, wait.
Power, force.
It's any time.
What's the correct answer then?
Displacement first. Because I think it's C.
No, it's not C. How can force be a scalar? Force has got direction.
Oh, sorry. So it's D. No. Yeah, it's D. It's D.
B. This is all level.
Doesn't power need doesn't power need displacement?
Power does not have power. It's watts. Power is nothing to do with direction. Are we together? Displacement is distance with direction. Force has got direction. Those are vectors. Acceleration is a vector. Velocity is speed with direction. Power is never a vector. Pressure has got a vector, but it's direction. Are we together? Power is nothing to do with. Are we together? So power is a scalar. So what's the answer? B.
B.
A cathode ray tube displays a square wave as shown. The base time setting is 0.2 per division. What is the frequency of this square wave?
Okay.
Frequency.
Okay, so you calculate the period first. It should be number of boxes in a wave in one wave multiplied by the time base setting, which is 1, 2, 3, 4, 5, 6 multiplied. Okay, wait. Then the answer would be B.
How did you calculate it? What is your period?
Okay. So first I changed the time-based setting to seconds.
Yeah, which I agree.
By multiplying it by. Pardon?
Yes, I agree with that.
Okay.
Yes.
And then I
multiply by how many
by
divisions? Yes.
By 6.
1, 2, 3, 4, 5, 6. That's what you said. Okay.
Yes.
So you said by 60. Then you know that frequency is what? 1 over what?
1 over period.
So this is what you're saying, according to you there. So to -3 multiplied by 6. Okay, so the correct answer. No. A measurement is taken correctly, but with a ruler at a significantly higher temperature than at which the ruler was calibrated. The higher temperatures or temperature causes the ruler to expand. What describes the effect of the measurement caused at higher temperature and how the measurement can be improved? Is it random error or systemic error?
It's random error.
You need to revise your definition of random. It's systemic error. Systematic error.
Oh, sorry, it's systematic. I thought that they like the experiment was taken at the wrong temperature, not the calibration. Sorry.
And how can that be improved? Is that the last part of the question? Yes. How can the measurement be improved? So what's the correct answer, C or D?
D.
D.
Yes.
The velocity of an electric car changes as shown. Velocity with time. What is the acceleration of the car? O level. So what is the acceleration?
Yes.
Calculate it.
Oh, thank you. Okay. Oh, sorry. 100. Then it goes down to. It would be C. No, sorry, not C. Okay. Okay.
So what's your answer?
I'm still trying to convert the item, the velocity to meters per second.
Okay.
Okay, it's D.
Number 6 is D, huh?
Yes.
Okay, correct. So we know the formula, V minus U over T, huh?
Over T.
But we have to convert kilometers per hour, like what we are saying, to
Meters per
meters per second. A projectile is fired from a point P with velocity V at an angle theta to the horizontal. It lands at point Q, a horizontal distance r from P after time t. No, okay. The acceleration of free fall is GA resistance is negligible. Which equation is correct? So R is the range, I'm sure you know that. V is what?
V is the velocity.
Okay.
Okay.
T is the time. Okay.
Yes.
So if you want to calculate horizontal, the range, what do you get? How do you get range? Does range have anything to do with the vertical component of velocity?
No.
No. It's only to do with the horizontal.
Yes.
What's the correct answer?
So you use sockets for opposite adjacent over hypotenuse. So you use so it's not B or C. It could be, but it's not. I mean, since air resistance is negligible and it's going up, so I think it's C.
We are forgetting things here. This thing is moving, this range here, it's movement in a straight line. It has nothing to do with G. Altogether, G affects only the vertical component. So the horizontal component, I simply bring this down. So the horizontal component is V cos theta. Then the vertical component bringing up here is V sine theta. But it's the one that is affected by G altogether there. Makes sense?
Okay.
So this one there
So it's A.
is simply this, that's the velocity, times the time, because distance is speed times time. Makes sense? If they now said calculate the maximum distance here, this can reach altogether. The maximum distance, that's now where you are using what? S is equal to UT plus what? Half AT squared. Clear? Where this is my initial velocity. So it's V because now it's moving in the vertical altogether. So it's V sine theta multiplied by T minus, because now I'm moving against gravity, half GT squared. This one here is for the maximum height there. Clear? That's this projector will reach. Make sense? A car accelerates from rest in a straight line with a constant acceleration. Which graph represents the variation of momentum of the car with the distance traveled? Momentum. With the distance traveled.
Yes.
Oh, you're still thinking.
Yes. real problem of constant acceleration. So I think as distance increases, momentum would increase. So I think it would be yeah,
formula
I think it would be.
From which formula are you deriving though? No, I'm talking to myself.
I was using P is equal to MV.
Constant, what's the keyword here? Constant what?
Acceleration.
Acceleration. Constant acceleration. Okay. So you're saying you're using the formula P is equal to MV, but that doesn't have anything to do with distance. Because here we're talking about distance.
Oh. You can use the formula of force times distance.
Force times distance. To get what work done. Because there you need to relate distance with momentum, huh? From your formula. Or displacement with momentum. So what do you think? Hold on. The numbers is wrong. So did you figure out how we do that? I'm begging. Are you there?
Yes, I'm here.
Do you figure out from your formulas? Force is equal to, like what you're saying, MA is V minus Z over T divided by whatever. V minus U. Force is equal to what? MA.
This is MA.
Force is equal to MV minus U over T. That's true. V minus U. So Ft is equal to what? Which is impulse, is equal to mass times V. Is your rate of change of momentum. True?
Yes.
So Ft is equal to P, momentum. Clear? Mass times velocity. Or change in momentum if I want to put it that way. Delta P. Is that true what you're saying?
Yes.
that Ft is equal to change in momentum. But they said the change in momentum is constant. So what's the corrective?
I think it's B.
Why do you think it's B?
Because if the change in momentum is constant, then, like, do you mean it's constant? Like, the change is like, no, wait. Okay, I think it's B or D between the two.
B or?
B or D.
Force is directly proportional to. Because the force.
Directly. Mm-hmm.
Okay, I see I'm mistaken. So still there we don't have force. Huh? We need what? We need distance. Huh? The formula is okay, but you see, there's nothing to do with force. Huh? If we were drawing a graph here of force, yes, if it was force and whatever, maybe it would be this, huh? Like what you see. But it's nothing to do with force. Huh? It's to do with distance here. Distance is what? Is displacement. So how do you get the distance from that formula then? Distance is speed times time. Yeah, so how do you get the distance? I think that's why it's tricky. How do you play around with the formula?
Okay, I think you can substitute one of the values for distance, like for the, for distance.
Well, where do you substitute? Yes, I get your point. Maybe you're correct. So you're saying we can substitute.
You can substitute, you can go to the formula for F is equal to MA maybe. And
I
then
mean, if you go
change.
here, you're saying M A multiplied by T is equal to momentum like this. Then we change the acceleration. That's your suggestion. No?
Yes.
And what is acceleration? V over T.
Acceleration.
Change in velocity.
Yes.
Over T. Multiplied by T.
And then the T's would cancel out. So
If you cancel the T, you come back. You come back to this. If you cancel the T's, you come back. Okay. Unless you say this is equal to S. This is equal to distance here. That mass multiplied by S over T is equal to P. That makes sense, then.
So according to, yes. So according to the formula, if S is to increase, then momentum would also increase. So it's B.
Clear now. A resultant force F of a raindrop of a mass m falling with velocity v is given by that equation. F is equal to mg minus kv squared. I've got a terrible flow there. I'm not sure if I will last 2 hours. I've been having a flow for the past 3 days. I hope it's not COVID. What is the velocity of the raindrop when it reaches the terminal velocity?
So you make V the subject of formula.
Okay.
So it will be mg over v squared, no, mg divided by k. Square root of that.
That's correct what you're saying. What do you know of the resultant force at terminal velocity? Be careful there. What do you know of resultant force at terminal velocity?
At
0. Remember, the air resistance becomes equal to the acceleration altogether. So force is 0. Clear. Otherwise, if you don't get that, then the rest is wrong. Huh? So this is 0 here. At terminal velocity F, resultant force is 0. So it means mg, like what they're saying, is kv squared. So it's simply making v the subject of the formula. Okay.
Yeah.
So the key comes on terminal velocity, resultant force is 0. If you don't do that, you don't get it correctly. Next point. A stationary toy gun fires a bullet. Which statement about the bullet and the gun immediately after firing is not correct?
I think D is not correct.
Yes, correct answer. What does this do with your Isaac Newton laws of motion? Number 11, application. Which describes the force acting on the block when it is sliding on a constant velocity.
I think it's D.
Frictional force is always against G, against the weight, which is up the board. No, what did you say? D.
Yes.
Which statement describes a couple? A couple. A couple. A couple. What's the correct answer?
To be honest, I don't think I've seen, like, I've learned this word yet,
Couple.
or the definition of it.
But you know it, huh?
Yeah, I know the basic meaning of it, like the English meaning of it, but like not the physics meaning of it.
Yeah, no, I don't think of couples. Physics. So just like your steering in your car, so you've got your pivot here. Then you've got a force like this. So let's explain it in simple terms. I've got a force acting what? Downwards. Huh? Then the distance here is d from the pivot. Huh? Then remember your hand is on this other side. Then you've got another on this, huh? Like this. Remember your hand is pulling, this one is pulling up. Huh? But can you say this is clockwise? And this is also what? Clockwise. Huh? And this is d. Can you see that? So this will cause a turning effect. Can you see that? That is actually the same force here multiplied by 2d. Huh? That makes sense. Turning effect. That's what we talk about a couple. Huh? So it's a pair of equal forces, you see? A pair of what? Equal forces with what? A pair of equal forces from what you said, equal magnitudes, huh? Acting in opposite directions, which produce a rotational but not translational motion. How together? It always produces a rotational force. Clear, man? That's your definition there. They've defined it for you. So the correct answer is 12. Yeah, that's what you mean by a couple. A uniform rod XY of weight 10 newtons is freely hanged to a wall X. It is held horizontal by a force F acting from Y at an angle of 30 degrees. So, okay, like that. Let's see the physics behind. What is the value of the force F? Holding. So is it in equilibrium? It's in equilibrium. Huh? You can agree, huh?
Yes.
So equilibrium, what do we know? We know that clockwise moment is equal to anti-clockwise moment. Eh? Are we told the distance?
No.
But we are told the weight. Huh?
Don't we use SOHCAHTOA?
Don't you even think of SOHCAHTOA? You complicate life. Huh? So what we simply need is to bring this force what? At 90 degrees, perpendicular to the distance, like this. Huh? So if I use cos, it goes down. Huh? I want to use what? Sine. Turning away from this. Huh? So it's F sine what? F sine. Do you get it now? If it was a horizontal component, bringing it down, it would be cos. But I want to bring it up there. So it's F sine what? Sine 30. Sine 30 is 0.5, by the way. Altogether. F sine 30 multiplied by the distance of this to that, to the pivot here. Altogether. Which I can call x. Multiplied by x. So this provides a what? What direction is this? Anti-clockwise. Huh? This one is providing a clockwise moment. The weight, my assumption or the physics assumption is that the weight is on the center of this. Clear now? So it means it's equal to, what is that? 10 newtons. Multiply, what is the distance? It's halfway. Huh? So it's x divided by what? By 2. Clear now? Make sense? Then when we divide both sides, that cancels out. So F now is now equal to 10 x over 2 divided by, if you want to put it that way, 1 over x sine 30. Yeah? The x cancels, the x cancels. Huh? Sine 30 is 0.2. I'm sure you know that from your thing. Huh? Make sense? Makes sense now. You see the physics behind that. So this is 10 over 2 sine 30. Use your calculator. You'll find that the answer is 10. Do you need me to repeat that?
Yes, please.
Okay. So physics by now. By the way, I think I'll send you a link video. And you've got internet at school. There's a guy called Dr. Physics. He's very good when it comes to these topics here. Okay, so now look at this. Dr. Physics LF. I'll send you the link. What I said is we need to bring, remember, because if I define, how do I define moment of a force? Is the force times the perpendicular distance. Perpendicular. So force and distance should never be at one edge. They should be 90 degrees to each other. Are we together? Just like this. This force here is 90 degrees to this distance. So it means I need to bring this along this. Are we together then? So it's the vertical component of this. Make sense? So because this angle is like this, I hope it's making sense like you. So this is simply F sine 30. If you wanted to bring it down, it would be F cos. Make sense? So this is simply F sine 30. I hope it's making sense, the first part there. So we now have this force like this. Then we say the moment is clockwise moment is equal to anti-clockwise moment. So the clockwise moment is this one here. So I said the distance, let this xy be equal to x, the distance. So the moment provided by the anti-clockwise moment is F sine 30 degrees multiplied by x. How do you get that? Which is equal to the weight multiplied by is half the distance, because the weight is central. So that's why I said x over 2. If you use your calculator, this is 0.5, by the way. So this is actually 0.5 x multiplied by f is equal to 10 x over 2. Then we simply divide by 0.5 x. So f is equal to 10 x over 2 multiplied by 1 over 0.5 x. This one cancels that. Makes sense? 2 times 0.5 is 1. That's why I said 10 newtons. Clear now?
Yes.
Four combinations of vectors are shown, each representing all forces acting on an object. The forces all act in the same plane. Which object is in equilibrium? The object is in equilibrium. Which combination of vectors should represent forces acting on the object? Object is in equilibrium. So which one there? Start all of them. And tell us which one you think. Oh, sorry. So which one? Forces acting in equilibrium.
I think it's A.
Equilibrium.
Okay, let me try again.
Forces acting in equilibrium. Balanced forces. D is obvious. B is wrong. You know that. There's no equilibrium.
Oh, I think it's C.
C.
Yes.
From my physics, without even saying, the resultant force of these two forces here is this, is somehow along this. How can these two be in equilibrium? That's not correct. But look at this here. Look at your arrows there, and look at this. So if you join them there, you're going to have another line like this. So these forces are what? Huh? Does that make sense to you there? Equilibrium.
So what's A?
Yes? What I
So
say?
what's A? What's A? How would you describe A?
Now, what you figure out is pick any two forces. Huh? Then always so if I'm to work with A, whatever the angle there, the angle, if I was to do this, because this looks in a funny shape like this. I'm sure you know that we draw something like a parallelogram like this, like this. So you see that this resultant force of these two forces is actually acting like this. So there's no way this force and this force going up like this will be in equilibrium. Can you see that? Because what I simply need is to resolve any of the two forces and just figure out with the third force if, or the third arrow if they can be in equilibrium. Does that make sense to you? So we can't have equilibrium thing. So that's why now all I did was to resolve these two forces like this. Then I checked the third force. So if I'm to bring it here, it will be exactly like this, and they are in equilibrium. Clear?
Yes.
What is the density of the metal? A rectangular bar exerts a force of that which rests on a height metal bar 80 centimeters. What is the density? Okay. Pressure, density. Do your calculations. Let's see if you get correct. Ngoja no. Ngoja. Shi? Again does it? Shagata ngari. What is about Google? On the internet, more research. That's in Baba. I'm telling you, just do your shagapendi. Oh, sorry. Did you get the correct answer then? Sorry, I was thinking that.
It's D.
What formula did you use? Because maybe there's something wrong with your units. Tell me, what did you do? So let's walk step by step. What did you say?
I used it in the wrong direction, I think, maybe. But I used rho GH. Pressure is equal to rho GH.
Pressure? But that's pressure of liquids, huh? Well, let's see, maybe you're correct. On a surface, huh? Okay, that's correct. Pressure is equal to rho GH. Okay, this is correct. So what we want is what? Is density, yeah? Which is equal to P over GH,
P over
which is equal to 15,200 for this pressure divided by 9 point what? Is it 9.81 or 10? I'm not sure. Should be 9.81 according to your syllabus. 9.81. So multiply by what?
0.8.
0.8. And what do you get from the calculator?
B.
B, huh? Be careful of B.
Yes.
Remember, this has to be 0.8 meters. And even you can tell from this meters, huh? A mass is attached to the lower end of a spring, bounces up and down. At which point in the path, symbol pendulum, at which point in the path of the mass, the gravitational potential energy of the mass elastic potential energy in the spring, and kinetic have the highest values. Highest values. Where do you have the highest maximum velocity when it's in a pendulum?
In the middle.
In the middle. So that's where you have your highest kinetic energy. Which means A and D are out.
I think it's C.
And your potential energy. So you're saying your answer is what? C.
C.
Okay. A block of weight, you see, 8 newtons is pushed a distance 60 centimeters up a slope inclined at what? 30 degrees to the horizontal. The block has got a frictional force of what? 25 between the blocks and the surface on the slope. What is the work done against the gravitational force? And the work done against the frictional force. The work done against the gravitational force. Work done against see the same things that I was talking about. So calculate it. And see what answers you get. Frictional force. Are we pushing it down or up? Up, huh?
Pushing it
Up the slope.
Oh, yes.
So if we are pushing it up, friction is where? It's this one, right? Moving in this way. U is this work done there against friction. That's your WG there. Clear there?
Yes.
Then your thing, your gravity is this, huh? Which is moving what? G, huh? Weight, like this, huh? So it means your work done against gravity is this one, huh? Which they call W what? WF. Clear? Tricky question.
I don't know. I think I'm doing the wrong thing because the answer that I was getting isn't part of the answers there.
Look
Because
at there we can put a parallel line here. And we can have a parallel line there. We know that alternate angles are what? Are equal. Okay, what I mean by this. So This force here, you see that it's an angle here. So this angle there is what? Is 30 what? 30 degrees, huh? Anyway, this angle here is 30 degrees, huh? I'm using this. So to resolve this force here, okay. Remember we were thinking of this, okay, sorry, but no, sorry, I'm doing the wrong thing. So we're saying alternate angles are what? Are equal. So this angle here, remember I'm trying to do a line like this, huh? Which is more like parallel like this anyway. So this angle should be 30 degrees, that's what I mean, 30 degrees like this. So if I want to if it's 30 degrees there, this one will be what? I hope it's making sense. Maybe let me. You've done this question before, but if you don't know this now, these forces here. Okay, I'll rub this. So what I mean, I'm not sure how you're doing it. I was thinking of this. Okay, well, but the trick thing is it's at an angle. Clear. So I'm saying the center of whatever is there, and you will see my arrows like this. Huh? And there I'm also trying to resolve it like this. Huh? So it's like I'm trying to bring this in this line, huh? So that I can work with the work done against this. I hope it's making sense. Huh? Work done against what? Against this. Are we together there? So do we use cos or do we use sine to bring it in this line, this 80 degrees there? We want to bring it like that. That's what I meant.
I think we use sine.
Remember, sine is when we are moving away. Huh? Cos is when we are moving like that. Huh? Like, for example, this force here, this friction, which we are going to talk about now. We also have to need to think of in terms of resolving it. That do we use cos or do we use sine for that force? You know, because it's also at an what? At an angle. Does that make sense? Yeah, thinking of the geometry. So what did you say there in terms of geometry? So you said we use sine. What is the work done against gravitational force? And what is the work done against the frictional force? The work done against. So what did you say? You said 80?
I said 80 minus 25.
Why 80 minus 25?
Because there's a frictional force between
the block and what? And the surface. This friction is this here. There's nothing to do with this one
here. Okay.
The friction force is between what? Yeah, I get your point. No, you're actually correct. So you're saying what is the friction? No, that's actually correct. The friction is in the horizontal and is also in the vertical component. Yeah? Clear now?
Yeah.
So now, okay, which is fine, which is what you've said is correct so far. Now, because we're talking of the frictional force. Now, what is the frictional force in against the gravity? What is the frictional force against the gravity? Maybe if we can put it that way. What is the frictional force against the gravity? Frictional force against, think of the frictional force against gravity. That's your W what?
WG.
WG. Is it WG? Read the question again. WG, okay, is the frictional force against gravity. Okay. And WF is what?
is frictional force against, or work done against frictional force.
Is the work done against the frictional force? Okay, work done against the frictional force. And so, okay, we're talking of the work done, which is force times distance. And no, sorry about that. Work done against the frictional force. Okay. So let's start with the work done against the gravitational force. What would that be? Work done against the gravitational force. Do we do F cos theta? That's what you need to figure out. Or do we do F sine theta? F cos theta or F sine theta? That's what you need to figure out. If you've got a plan like that, I'm sure you've learned maybe plans like that before. So do you do F cos theta or F sine theta? Work done against gravity. You see that? Against what? Gravity. So you see your gravity is what? Is this, huh? The 80 newtons there. So it's 80 cos what? What is 80 cos theta from a calculator?
Um, 12.
Mm-hmm. You get?
12.3.
12.3. Work done. 12.3. Okay, that's the force, huh? And what is the distance moved? Against
It's
gravity.
0.6.
Where did you get the 0.6 from? 0.6 is in a straight line. Your gravity is a vertical component of the force, huh? Your gravity is a vertical component of the force. So can it be, it can't be 0.6, huh? Is this distance, is it correct? This perpendicular distance here. Are we agreeing? Or I'm wrong?
So, yes, I agree. Okay.
So which would be sine, huh? Sine 30 is equal to, oh, okay, so it's 6 times, which is 3, huh? We are not sine 30 is equal to x over 6, which is equal to 6 sine 30, which is 3 centimeters. It's giving us 36, which is not correct. Cos times distance. Let's see. 25. Poked along inclined at a distance, the frictional force between the block. Okay, wait a moment. Wait. Let's agree here. Unless, what do they mean by against? Maybe I'm not understanding the English here. What we should agree is, what's the resultant force moving upwards along the vertical? What will be the resultant force? I have to move it along the horizontal. What will be that resultant force? So what do you think? It's a tricky question. What is the work done against gravitational force and the work done against frictional force? The frictional force is 25. Okay, let me try to make sense of this. The frictional force is 25. So you're saying 80 newtons I'm missing some geometry. This force is, the frictional force, we agree that is in this direction. Is that true? 25 newtons, huh?
Yes.
Then this one is in this way. But we said we were supposed to bring it in this direction so that it's at 90 degrees to that. That's why I was saying, but wait, I was thinking of 30 degrees here. Wait a minute. Like that. Okay, I get it now. So you're saying this is 25 newtons. This is 30. Okay, wait a minute. I just need to say something here. 30 degrees. Let's have the correct geometry there. That is 30 degrees. But it's obvious if we bring this line straight like this. Like 90 degrees. So that is 60 degrees. Then this angle 30 degrees here. So that we do 80 cos 30 to bring it in the horizontal. Is that correct?
Honestly, this question is confusing me a lot.
Confusing. Do the geometry. Remember, what? Okay, do you know? I will give you an idea. What you need to think of is to bring this 80 newtons in the vertical component, okay, and also to bring it in the horizontal what? In the horizontal component, because we know that the friction there is working against this. Yeah, then we've got your W, your work, which is because you're trying to push it in this way. So that's why I was working with the mg or with the gravity here. Then okay, this should be mg 80 cos 30 degrees. So 80 cos degrees is what? 12, huh?
Yes.
12.3 meters. Mm-hmm. 12.3 newtons. Weight done against gravity. Okay. Then, and if you do 80 sine theta, what do you get? 40, huh? Eighty sine theta is what? Is that 40 degrees?
sine theta is negative 79.
80 sine theta. Which calculator is it? That should be 40 degrees. 80 sine theta. That's not a negative. Yeah. Sine theta is 0.5. So how can you get a negative? 80 sine theta.
Yes.
So what do you get? Should be 40 degrees. 40 newtons.
No.
Is your calculator is your calculator in radians or in degrees? Make sure your calculator is in degrees. I'm sure you're using your calculator in radians. In degrees?
Yeah. It was in radians. Yes, it's 40.
40 degrees there. So when we do that, we are resolving it horizontally. Huh? Then now we subtract 25. Then we get 15. But anyway, this question is confusing you there. Have you learned this at school? This topic? Not yet.
Probably. Yes, I think I've learned it, but then it's just a bit, physics is just a bit rough for me.
Oh, okay.
It's a bit shaky.
It's fine. Can you now go and revise? I'm going to send you. So what I need you is go and revise on the momentums and the pulleys. I'll send you the videos just now on this.
Okay.
Then we try to do lessons there. But your physics, it's rough on you. Physics is maths. Are you good in maths? Yeah, good in maths, huh?
Maths is very different from physics.
Yeah, maybe it's your physics teacher, maybe the approach that you used. Because if you are good in maths, you should be enjoying physics at the same time. So now, anyway, so let me send you now. So go through the momentum, but go through the pulleys on that video there. And the projector that I was trying to explain, because it's now in your syllabus, the projectors, very easy. I think it will make things easy. Sometimes it's the way things are explained. Okay. So maybe try to do that today. I will send you the links just now. And we catch up from there. And I'm not feeling, I think I've got flu or something. Let me send you now. Okay. Can I send you an email? How do I send you? I'm forgetting your notes on WhatsApp. So I have to send you an email. Is that correct?
Yes.
That you're not allowed phones.
We can have, I have my phone right now. You can send a WhatsApp now.
But someone was saying.
But then I don't. Yes, I don't normally have it.
You don't normally
have it until 5:30 today. Yes. I'm handing it in later on.
Also, you have to hand it in.
Yes.
Okay, wait before I even forget. So that I see there. So it's topic by topic. Huh? So what you do is you go to a link called Dr. Physics. Huh? But the link that I'm sending you is not. Let me see if I can get the correct. Wait. Doctor, yes, I found the physics. Doctor, let me see if it's the correct one. So he said right now here, you still have your phone. And you're ending it very soon. 8 live, okay. Wait. Confirm you have received the link.
Yes, yeah.
You see, there's mechanics. There's the torques and the couples, moments there. You see that? Then there's moment in 2D, there's projectile, circular motions. Can you see that? Then where this is explained under where there's called the banked turns there. Can you see that? I'm sure you can see a diagram of what the question almost similar to what we're looking at.
Yes.
Yes. So the guy is very brilliant. Just go through them and ask me further questions.
Okay.
Okay. So we'll see you tomorrow then. Then maybe tomorrow what I'll do is let me bring some questions like that tomorrow. We try to do
Okay.
many questions on such systems. So I'll bring a worksheet, then we'll be working together. Clear now. But now if you go and read now, then tomorrow you're on the same page. Okay.
Okay. Thank you.
You're welcome.